So let me create a folder called Volve underscore buttonhole pressure. And I'm going to create a new notebook. So first of all, let's start by importing the data and visualizing the data. So we're going to do this by using pandas. Let me zoom in because I know that this can be quite tricky to follow through. So let's import pandas as PD to explore the data frame. And the information that we're going to use, it's located in this data folder. And it's the Volve production data is actually in this folder, production data. So the only thing that I'm going to do, it's I am going to use this link and copy this link. Okay, and directly from that URL, okay, I have that URL. So directly from that URL, I'm going to download the data and load it into a data frame. So this is my production data frame. And we're going to read this as an Excel in pandas. So now if I show you what we have here, and I need to zoom out a bit, I have let's take a sample of the data that we have. And if we take some random sample of the data, let's take just probably 5 rows of data. You can see that we have here dates. We have also information about the wellbore code, some internal wellbore code that Equinor had at the time. We have the name of the actual name of a well, the name of a field, and so on. Facilities name and so on. Some of this data, it's going to be useful for the purpose of the machine learning, and some of the data is not going to be useful. And actually, you can see that there are some spurious values that we have in the data. So that's as part of a machine learning process. Although we talk about using machine learning models, cleaning the data, what is called imputing, replacing values by some more values that have actual sense, is part of a duty that someone that is working on, or data scientist or someone that is working on the data would have to do in order to perform machine learning. So let's explore a bit more the data. A few things that I observe here is, as you can see, there are some more columns here. So let's explore all the columns. And if I just check the columns, and let's list the columns. You can see that we have all those names. And one thing that I noticed, for instance, is I didn't know what was this particular name. So if I explore just that name, I realize that is just a symbol there. That is a percentage symbol. And what I realized is that this was related to the choke size, which is, I think it's this one. Now this DP choke, I believe. Yes, it's a DP choke. This other choke size, it's on 64th pieces of size of equivalent. So some of these columns we will have to clean before we use any machine learning technique. So this is what I was trying to tell you about the choke size. So if we take, for instance, just the columns prod, let me take just a few columns, such as this one. Let's take this one. Let's take this one. and let's take TP chalk size. I think for the later on when we use machine learning, and let's take only the first 10 or 5 values, we can see that this is percentage. This is actually the percentage of opening, while this is a fraction on the 60 or reference of 64th of aperture. So this is really the one that we're going to be using. I have done some more work. If you see all these names, I have changed a bit the names, and I'm just gonna copy paste some of I'll do 3 of those, and then I just show you what we're trying to do here. But we have some column names that we want to clean a bit, just to be able to. So for instance, I have date prod, Volve code, and so on. I'm just gonna take some of these. And what I'm going to do is slowly but surely start to replace all these with some names that at least are meaningful to me. So these are dates. These are I think these are the well IDs, and these are code. The Volve code. This is a well-named code. So this is a dictionary that I can use to replace all the name of these columns. You can imagine it almost like in Excel, replacing the name of all these columns in one go. So what I'm going to do is copy, show you the rest of the names that I use here. So I have all those names there. And now I'm going to replace all these columns. So in order to replace the columns, I can go into this data frame and then use a rename functionality. So I can use a rename, and I can set that my columns are going to be equal to the column names that we specified just before. Okay. And I'm going to replace this completely all the columns. So in one go, I can do it with the in place equal true here, just to make sure that I replace all the columns in one go. So if I do that, and if I show you the information here, now I have dates, well ID, well name code, well name, and so on. And of course, this is great. And another thing that I noticed is that there is this column called well type and flow kind, which is a bit useful, but because at the moment we are only focused on the producers. This is something that I would like to do for the producers, but there is nothing stopping me to do it for the injectors. So we have a water injector category and the oil producers. So what I'm going to do is filter my data frame by using just the well type. The well type has to be exactly equal to oil producers. So I just would like to get in the data frame. Sorry, data frame. My well type, it's going to be equal to oil producers. Okay. So I'm replacing all that. Oops, what happened there? Okay, sorry. Okay, and if you see here, let's see. We don't know. Okay, so this will have. Oh yeah, you can see here that we have 15,000 rows. But now, after running this, see shape. we have almost 9,142 rows because we are only focusing on the oil producers. So out of the wells that we show here, some of these wells are injectors. I think there are probably a couple of injectors, and we would like to focus only on the oil producers. Okay. So that's fine. And so there are a few other things, few other properties that we may need to drop for later on. And probably this is a good moment to talk about the next part, which is data cleaning and data handling or data preparation. So let's call this my data preparation. Okay. And before I get into data preparation, let's talk here quickly in one slide and talk about why we need data preparation. So we have a lot of different type of data in that matrix. And some of them are going to be useful and some of the others are not going to be that useful. And we need to spend some time cleaning the data. And that is very typical in pretty much any machine learning project that you're going to find. You will have to spend quite a few time just cleaning the information. So what I'm trying to do here is, let's say, we have, for instance, of course, we have a oil volume. We have a water volume. And we have the tubing head pressures and so on. But we have some other properties such as well ID. So well ID, it's do you think it's something that will correlate in any way to the bottom hole pressure? So no, yeah. So this is probably a number that was fixed randomly, or probably it was just aggregated based on when the well was drilled, the time. So it was just the previous well ID plus one, and so on. So that's something that we don't really need to use for any model. So another thing that we could think about is we are not going to treat this as a time series. We could treat that, but we're talking about another type of machine learning models. So dates is not something that we will use in this particular case. Let me put this, actually move this down a bit, and this down a bit. So we have some things that we're going to be used. And we have some other things that are going to be dropped. Okay. So anything that has ultimately we would like to come up with something that is bottom hole pressure is a function of probably oil volume, water volume, THP, and so on. But there are some things that we would like to drop. Yep. So another thing that we would like to drop, of course, is that percentage choke symbol. That has no value if we're going to build a sort of function to predict the bottom hole pressure. Okay. So that's more or less where we are heading with this data cleaning, and this is just one step. And this is this step. In this case, we are what we're trying to do here is identify features for the ML model, for the machine learning model. Okay. And for you, anyone that is has some technical background could see some of these features and could say, well, if obviously the facility name Maersk Inspirer, it's not something that will correlate necessarily to the bottom hole pressure, and in fact, it's the same name. Okay, so having said that, let's start by dropping some features. Okay, let's drop some columns. And the columns that we're going to drop, I have them already here. And the first set, I will call it the first set to drop. It's these numbers. So I don't have anything to do with a well ID. Casing pressure, I took it out. Maybe we can try to put it in. I don't know how many hours the well was on a stream. Perhaps we can see later on. The well name code, nothing to do. Field name, field choke, choke size. Choke size has, but remember from the previous explanation, we're going to retain not both choke size. We're going to retain the DP choke size, which is a choke size percentage in the table. So that's what we call choke size percentage here. So that's why we are dropping it. Flow type, we don't, if it's a well type, WI or the OP or flow kind, we don't need that. And the water injection, we don't need because we're focusing on the producers. Okay. So we do that. And the way to drop now is we're going to have now a new data frame. And this data frame, this data frame production. I'm going to drop all these columns. First set to drop. I'm going to drop all these columns. And I have to put this just to make sure that I specify that I'm dropping columns and not rows. Okay, so if I do the header, now we can see that we don't have some of these names there. And now we're going to use this name df to go forward. Okay. Let's see something else, and something that might be interesting to see here is the information. And in this information, we can see the number of non-null values and also the type of objects. And you can imagine here we have well name, dates, that we have to, well name probably is something that we cannot use in the machine learning model. We can use numbers or some sort of categories converted to numbers, but not objects. Non-null means that there might be some issues with some of these values. Okay, so and at this point you may have to decide what you want to do with these issues. So, and this is where probably a data scientist will still need the help of someone with domain expertise to decide what to do. So that's why machine learning cannot be done necessarily without the domain expertise. You need someone to understand whether you want to retain some sort of values, replace those non-null values. So let me show you what I'm trying to say with null values. If we see the data frame, let's bring the count of null values. And you can see that the bottom hole pressure, there are 165 rows where the bottom hole pressure has not a number. So they has a value that is not a number. So what I mean with is not a number. I mean that if let's filter the data frame where the bottom hole pressure is null. Okay. And let's see what we have there. So what you see here is some of those columns are null. And what you can see also is that where that is happening, most of the time, the oil volume is 0. Gas volume, so the well is shut. So we might be able to safely, we might be able to remove those values and predict and try to feed a model where we predict the well only when the well is open. Okay, so we might be able to produce a couple of models, one for the well when the well is open, one where the well is shut. But we may have a problem there, and we will go to that in a second. So in order to handle this, we can do a drop NA. And in this case, I'm dropping any row with not a number values. So these 165 rows, 14 and 6, they might disappear. So I'm going to do the in place just to replace the values directly in the data frame. And now let's run the same code here to see what we have now. So we have eliminated all the null values or the non-number values from the table. And actually, it shouldn't return anything. So everything is clear from not number values. One more thing, because we already filter the data frame with the oil producers, I think it would be interesting to save the well names. And the well names, I'm going to save it from the well underscore name, and I'm going to get the unique values. Okay. And here I'm going to print the well names, and there you go. So we have 5 wells. 5 wells, as I mentioned from the slides, and we would like to take probably 2 of those wells for training the machine learning model, and 3 wells for prediction. Okay. Right. Now I'm going to run somewhere here that is going to take a bit of time. Let's leave it running. But so let's see how this ended up. Okay, so now we have only data for this well. We don't have another number values. And actually, let's see the size of the shape of a data frame. We only have 8,978 rows, which corresponds to this is daily production, by the way. Sorry if I didn't mention that at the beginning, but this is a daily production from the